Nick Seiter, is a field crop entomologist with the University of Illinois. His research and extension program is focused on developing integrated pest management recommendations for soybean and corn farmers in Illinois. He has a Ph.D. in entomology from Clemson University and a bachelor's and master's degree in entomology from Purdue University. Today, Dr. Nick Seiter will speak on how defoliating insects are the most common pest encountered in Illinois soybean fields. We will discuss the relationship between insecticide residual activity, levels of defoliation observed in Illinois and throughout the Midwest, and the timing of the insecticide applications. Please help me welcome Dr. Nick Seiter.
All right, good to see you all. Thanks for sticking it out today. She said I'll be discussing soybean defoliation, insecticide residual activity. Might throw in a little bit of material on dectes stem borer at the end if we have time. Feel free to yank me if I start to go long, and we'll make sure we get you out of here in a timely manner. Let's do it that way. Insect defoliation in soybeans. So again, as she mentioned, we see a lot of defoliators have a pretty wide variety of different insects that'll go in and feed on the foliage. Some of them that are pretty serious feeders on foliage, things like bean leaf beetle, things like soybean looper if you go far enough south. Some that are kind of wimpy, you know, we see some salt marsh caterpillars and things like that. We haven't gotten, I don't know how far people are coming in, we haven't gotten the painted ladies in Illinois so bad as they have in a few other places, these thistle caterpillars. Pretty consistently, we see bean leaf beetles, we see Japanese beetles, we see green clover worms. That's most of what we're dealing with. If it's a bad year down south, we might start to pick up some soybean loopers in southern Illinois, but relatively consistent cast of characters here. Our economic thresholds, haven't looked at them in a while. They've been 30-20 for years and years and years. We'll look a little bit at how that changes with prices, you know, how that gets adjusted as prices go up and that kind of thing, or how it should get adjusted. And then we'll talk a little bit about what we're actually seeing throughout the region. And I think most people will agree, certainly most people who have gone through and measured defoliation will agree, our thresholds are really high. If you've ever seen what 20% defoliation looks like, it's really high, like really pretty eye-opening. We'll talk a little bit about whether that's right or wrong. What I want to talk about first are some fields that we looked at throughout the region. And these were fields, ideally, that were chosen because someone identified a problem with them. So someone looked at these and said, we've got some defoliation that we're concerned with. That wasn't the case every time. Most of the time what happened with these, we tended to be looking late in the season because we were waiting and waiting and waiting for some defoliation to show up, and by and large it simply didn't. But we ended up ultimately with 65 fields, sampled 105 times. Most of these were sampled just once as defoliation kind of maxed out. I think over your buddies in Iowa State decided to sample every week throughout the season, which good for them. They did a lot more samples than we did. Better them than me, I suppose. But they collected a lot of data for this. And again, we were targeting fields where we thought at least that we might have a serious level. So out of those 65 fields, our average was right around 3% defoliation going through and measuring this. Again, for us, at least in Illinois, we're mostly waiting until R6 to get up to those kind of levels, to build up to something that we felt like we could measure. 57 of them had less than 5% defoliation. The less than 5%'s sort of just a benchmark I chose as pretty negligible, you know. So most of those fields, we wouldn't really have given a second thought in terms of any kind of a threshold. We had one that got up above 10% out in Kansas, right around 16% defoliation. My colleague out there didn't take any pictures of it. I wish he had. It probably looked pretty awesome. We did get to see one that averaged out at about 8.6% defoliation. That was only about an hour north of here. One thing I did want to show you is sort of what that level of defoliation looks like. Pretty bad. Looks pretty bad. What we're actually looking at here, down here in the corner along this border, we've got something like 20 to 30% along the edge of the field. And this was a combination of green clover worms, bean leaf beetles primarily. I'm sure there were a few Japanese beetles in there. They were probably long gone by the time we got out to the field. If you look down, you know, there's an area of the field that was right around 35%. And we saw in this particular field something that's pretty common for us, which is as we start to get further in from the edge, that level of defoliation starts to drop off quite a bit. Maybe the overall point of showing you this is certainly when you've got a level of defoliation that's important based on current thresholds, like you know it. It's not something you're going to pass up. But even when you've got relatively lower levels of defoliation, it's typically going to be something that sort of hits you upside the head. And we've been trying to collect a lot of these pictures of areas of the field where we take the picture and then we go through and we measure that defoliation. We'll actually measure it with a phone amp. You can go out and measure the area defoliation taken out of there. Takes forever. It's not something you'd want to do as a scout, but it's useful for this kind of thing. So here we're looking at about 5%. I think most people, if they saw 5%, would be pretty concerned about it. Maybe not to the extent that we had to wait until R6 to see it, but if you start to see levels like that, it's pretty eye-opening. 16%, this actually looks a little bit worse than the field did because it got pixelated when I compressed the picture, but you sort of get the idea there. 35% is rough. 35% kind of looks like a hailstorm. We've really only seen that one time in that one field that we looked at. Point of that being, the overall levels that we're looking at are low. They're mostly unimportant based on our current thresholds. But soybean prices have changed since these were developed. Certainly they changed since, I think this one's been the same since 1995 or something like that. They're a little different now. They're not what they once were. So I wanted to take you through a few scenarios here, and keep in mind the current stage in the reproductive stages is 20%. That's what it's sat out in Illinois forever. If you go and look throughout the Midwest, it tends to be pretty similar than that. Some people have it 25, some people have it 15. If you go to the southern U.S. where they get a little bit more defoliation, it's actually a little bit higher. I don't know if that's because they overestimate defoliation worse than we do, or if they're just more used to seeing it, but their thresholds tend to be a little bit higher. And what I did with these scenarios, I took the most recent attempt at taking this relationship between insect defoliation in soybean and yield loss and going back through and calculating updated numbers. And the most recent attempt at doing this was actually down in Mississippi. It was on group 4 beans, so not terribly different from what we do. Came up with pretty similar results in terms of a yield loss relationship to what we've seen in the literature previously. And if you look over at Purdue Extension's website, they've actually got a table set up with very similar levels, except they're based on old data and that kind of thing, old prices, old costs. But you can draw the line and see where it's going to end up. So I took 64 bushels per acre. That was the average yield in Illinois this last year, according to NASS. Took $14 a bushel. Seemed like a reasonable high price to throw in there. I've seen, what, $14.75? Are we up to 15 yet? I mean, yeah. It keeps changing, keeps going up. Control cost $8 an acre. I'm assuming this is a separate application. I'm assuming you're going out just spraying an insecticide. I know a lot of the applications aren't that. We'll talk about that a little bit later. And I do come up with a reduced threshold. So if you plug those numbers in, get about 8% at R3 and R5. It should go up a little bit at R6. That relationship between defoliation and yield loss at R6, you know, most of the seed fill's done. Takes a little more to amount to anything. Bear in mind, this is defoliation. We're not talking about any pod feeding here. Take maybe a little more typical scenario over the last few years, more of an average yield potential for the region, lower soybean price. Still lower than what we've had. What'd I do? Did I go backward? Still lower than what we've had in the past. Around 11% R3 to R5, 17% at R6. And then I figured I'd do one, what if we're really pushing it on yield? What if we've got a 100 bushel field? There's a few of those out there, more than there used to be. And we can drop it about to 6.5. Doesn't happen very often, but it happens. That's about as low as I can make it go if we're talking about a standalone threshold. But I get that question a lot, like what do these do with updated prices? Well, they do that, they go down. When we look at what we were seeing throughout the region, we're still, by and large, not above that when you compare that to the levels of defoliation that we're actually seeing. And this is part of the reason these recalculations don't happen very often is that typically they look at the relationship, they look at the levels of defoliation they're seeing, and they say, okay, who cares? It's good to revisit it when prices get high like this. We will be revising that threshold throughout the region. Obviously, it varies a little bit, right, depending on your yield potential, depending on what the prices are in a given year. I don't think they're going to stay at $14 forever, probably $15 forever. That would be my guess, but I'm not an economist. But eventually, they'll probably come back down. We're still looking at levels in the field that are pretty far, from the most part, from justifying a spray economically. For the most part. It does happen. It's not never. It's just pretty uncommon. Any questions on any of that or any of the numbers I used or why I used them? Be happy to talk through economic thresholds all afternoon. I do it all the time, but we wanted to take a look at what these are. And certainly, as you lower that control cost, I'm sure some of you are looking at that. Obviously, if you throw a $2 pyrethroid in with a fungicide, it's less than that. One thing I'll point out, most sensitive at R3 to R5 becomes less sensitive at R6. Again, where we're seeing insect defoliation that amounts to much of anything at all, we're having to wait till R6 to do it. Usually what's happened there, we have some Japanese beetles come in around R3, around 4th of July, and for the most part, who cares? They don't do a heck of a lot by themselves. But then we get green clover worms in on top of them, and in some cases like that field, we get pretty high populations of green clover worm. I know that's one thing some of my colleagues have noted that I seem to have gotten more reports of the last few years, is higher green clover worm populations maybe than we used to see. Those populations used to do a better job of falling apart, collapsing, perhaps, than they do now. But you'll get them. Usually what takes you to that level where you're over 5% and where you're starting to think about, well, maybe if the stars align, if I've got great yield potential, if I've got a really high price, if I've got a low cost of control, I can, that'll pay for it based on defoliation. Usually when that happens, it's when the beanleaf beetles come in at the end and sort of finish the job. That's what we've seen. Another thing to keep in mind, again, this doesn't take into account pod feeding, pod scarring. That, I would argue, is a much more important issue than anything you'll ever see on defoliation. If I manage it, I'll try not to do that again. If I'm managing that, I'm going to scout primarily for that pod scarring, looking for them at the time in a pod scarring. I'm not real worried about defoliation in most fields in Illinois most of the time. Part of the reason for that goes along with what we'll talk about next, which is how long are we actually getting out of an insecticide application? And that's something I think we end up with a lot of confusion on because it's sort of a complex issue. These insects, it's not like they, they're not coming in consistently the same way throughout the season. Different insects are going to show up at different times. They come and they go, they cycle out, they leave. You have different populations fluctuating in and out of this field all the time. So just because you spray an insecticide and the insect doesn't ever come back doesn't mean you got good residual control out of it. It means you killed them and they didn't come back. What we did to test this is we sprayed small plots. So we went out, sprayed the insecticide in the plot, and then at different intervals we collected foliage. We put them on this agar media. It actually had a fungicide in it to keep that plant from wilting. Put it on that agar media, put this benzimidazole in there, and the plant doesn't wilt. And then we exposed these insects to them. Worked really well with beanleaf beetle. We tried some things with stink bugs that they didn't like it so much. They didn't do so well in those petri dishes. We did all right with Japanese beetles as well, but we would go out at these different intervals and see if we've still got activity, if we're still killing bugs at 1 day, 2 days, 3 days, and so on. And this is pretty typical of what we saw. It's a fairly rapid drop-off, down to about nothing with most pyrethroids at about 14 days. Still get a little bit of activity with some of the premixed products at that time. Clearly starting to wind down when you get to 14, 15 days out. It's going to vary a little bit depending on the weather you see. Certainly if you get a rain right after, it's going to be quicker than that. Hotter temperature is going to make it go away faster. More sun is going to make it go away faster. Did some of the same things with Japanese beetles, actually. We're actually able to look at the amount of defoliation. That gave us a better indication of whether there was any residual on that plant than whether the beetles were alive or dead. Some of these things are pretty good at playing dead, so you've actually got to sit there and poke them with a probe and see if they wake back up and start running around. It's kind of fun. It's about exactly as high-tech as you would imagine it would be. So but here's what we look at, pretty dramatic reduction in the level of defoliation at 1 day. You'll see there's a lot of just background variability in these data. That's one of the things that makes this a challenge. When we get out to 15 days post-application, we didn't really have much of anything left. And again, we're falling off quicker with some of the straight pyrethroids, and this is a pyrethroid with a diamide in it, than with the premixed products. But still not getting weeks and weeks of activity. We're talking 10 to 14 days for most of the materials that we're using most of the time. Certainly no more than that for the average, $3 pyrethroid that makes up probably 80% of our insecticide applications. Here's what we see sometimes in the field. If we actually get an insect population that's coming into the field, we can sort of see this in real time with our counts. This is a Japanese beetle trial from, I think, 2018. Yeah, 2018. And you'll see again, 3 days after application, we killed them all. Japanese beetles, if you actually get a straight pyrethroid on top of them, they're pretty wimpy. Like, they're not a difficult insect to get initial control of. If you look at 8 days after application, you see those bars start to jump a little bit. So we're starting to get some re-entry back into that field. This was that rare scenario, and you really only see this a lot of times in small plot research where you had so many Japanese beetles in that area that they're actually coming back into the field. So useful for showing what we want to show, not necessarily what's going to happen in a field. What I thought was funny is by 15 days post-application, they're saying, well, why am I feeding on this leaf that's been all eaten up when there's all these clean leaves over there in the besiege plots, right down the road? So by then, of course, you had nothing left for this particular insect. Again, an insect that's not just especially difficult to control. You wouldn't see this as quick, or you'd see it quicker actually potentially for a stink bug or something like that. Green cloverworm, you probably wouldn't see it as quick. Of course, they don't re-enter the field very effectively. But the point of that being, you got to think when you're putting this application out, not necessarily, am I going to have an insect infestation this year? Like, do I have a good possibility of getting bean leaf beetles or stink bugs or whatever? The question you've got to ask yourself is, am I going to have this issue show up in the next 10 to 14 days? That's the sort of window that we're talking about here. So for instance, if you're putting one out at R3 and this is a preventative application, the chances that you're going to have something come in the next 10 to 14 days after that, pretty slim if it's not there already. Same even for R5, and when we look around in East Central Illinois, I would say most of the damaging infestations that we have tend to be later, and we're talking about pod feeding bean leaf beetles and stink bugs for the most part. And that's why when we talk about prophylactic insecticides, prophylactic foliar insecticides especially, and we're not real keen on doing that, this is a big part of that equation as well, is how long are we actually getting activity? How long is this going to do what we're putting it out there to do, which is kill bugs? And the answer in general is about 10 to 14 days. Mind you, it's better on day 2 than it is on day 12. It's not as if you're getting straight activity through that time and then it's going to drop off. So this is the reason that we really look at targeting active infestations rather than trying to prevent with these pyrethroid apps. I'll run through dectes really quick just because, I don't know, how many of you came here from Southern Illinois? From a no-till area? Yeah, we'll talk about dectes a little bit then. There's at least a few of you. This is going to be an insect that we've seen more of in recent years in Illinois, pretty tightly associated with areas where we have a lot of no-till soybeans. What's going to happen here, it's longhorn beetle. The beetle lives inside of this soybean stem, burrows the heck out of the inside of that stem, looks pretty terrible. The impact of that on yield is actually relatively minor. What it's going to do at the end of the season, it'll burrow all the way down to the base of the stem, girdle that from the inside out, and the stem will fall over. And that's where we can get some impacts from this, especially when we have a crummy harvest season. When it's wet at harvest, we can't get into the field in time. This girdling, it's driven primarily by the dry down of the plant rather than the developmental stage of the insect. So like if the plants dry down a little bit earlier, they'll go down there and start to do it. If it takes them a little longer, that'll be delayed. They make themselves that nice little hole there that they line with their sawdust and that sort of thing. You'll see this sawdust at the base of the stems, and that can be an indication that this is about ready to happen. So we wanted to do some work, and a lot of this was with cooperators. Really appreciate their help on this. We also took some sampling trips down here and took a few samples. I think you can see one of them, the ones that are in a straight line like that were probably us. Just going out and picking stems and seeing what kind of levels of infestation we're looking at with this insect. This is year 1 of it, so we can't, of course, look at trends over time yet. Looking at our hot spots really right down through here where obviously we have a lot of no-till agriculture. What we'll be especially interested to see is if over time we start to see this creep northward. There's some indication that that's been happening, though it's a little bit tough to keep track of because until recently, not a lot of people were really looking for these actively. But you can see we get up to around 64% of stems infested. And I mean, when you talk about a field that has 64% of its plants with one of these things inside there. That's a concern, and it's especially going to be a concern if we get into a situation where we have a hard time harvesting in a timely manner. What I'm really interested to see is if we get into some of these no-till areas in western Illinois, in northwestern Illinois, where we haven't traditionally looked for these things or seen these things, if we'll have them up there. They've got them in Nebraska, so it's not like our winters are too harsh for them or anything like that. But something we're looking at, and if you're interested in helping us track this thing over time, certainly let us know. We'll be trying to do this again going on into the future. Don't think we're going to find them in Champaign County. Not a lot of no-till here in Champaign County. I think I've seen one beetle ever running around in the county here. They do like sunflowers, so maybe over by that sunflower patch off the interstate we might have a few of them. But they also like giant ragweed, but I'm not looking in there. Other than that, that's finishing up a little early, I know, but I'd be happy to go through and talk about any other insect issues you've been seeing, anything you're curious about related to soybean insects. That's all.